Hello, YouTubers. In this session, I'm going to continue our discussions about concepts and principles in the engineering standard, or the standard for short. In the last session, we talked a little bit about the cul-de-sac pattern, where you can have your API subscribe to a queue, messaging queue, and then when a message comes in, it will trigger certain functionality within your API, and you will be able to persist that message as an object into your database, right? And this is a very common thing. It really helps you a lot with resiliency when you're building resilient systems. You don't have to make your client wait on the other side, until you actually process the request. You can just fire and forget. You can just take the request, through a gatekeeper or an API gateway. You can go and say, okay, your requests have been submitted. Check back again later, and then you just send it there off the queue and then move on, right? Now, sometimes the world is not that simple, right? Sometimes you will work with, enterprise applications that require a little bit higher level than an orchestration service, something like a coordination service or a management service. Let me pull out here the draw IO. Let's just talk about it for a bit, and then we will, see if we can make this idea or this principle simple to understand. So here's what we had. From a high level perspective, you have your API, and your API is sitting here, and then your UI, or it could be another service, it doesn't matter. Your UI basically is talking to some gatekeeper and putting a little messaging queue in here. Okay, so that's your messaging queue. And it's putting the queue message in here, and then your API is responding to it accordingly. See, notice that the arrow is coming from the queue to your API, not the other way around. So your API is not checking. It's not a pull pattern. It's a push pattern, right? So your messages are getting pushed into your API, and then your API responds to it by picking up the message and adding it to some database, right? That's the high-level architecture. This is what we call high-level architecture. You're talking about architectural components that work in your system. On the low-level architecture part, we went and said, oh yeah, that's simple. We have a queue broker, and we have a storage broker. So here's my queue broker, and here's my storage broker. Oh, excuse me. Here's your storage broker. And your storage broker basically is, basically just communicating with the database. So this is your integration or your liaison, while this queue broker here is the guy that's listening to the messages from the queue. Notice the flow, notice the arrows. This is, thought through kind of flow, and every little detail here really matters, right? So if I go here and say, okay, this is my queue broker, storage broker, we went and said, oh, just build a couple of foundation services on top of this, and then give me an orchestration service that I'm going to call it the student event orchestration service that will take that event from the queue and then go and persist that into the database. No harm, no foul. So let's just go here and say this is student event service. This is your foundation service. It can also be an orchestration service. Go back to the standard and understand these concepts. And then you have student service in here. And you have here student storage broker. And this is student event broker or student queue broker, like this. Q, how do you spell Q? Q broker. I don't know. All of a sudden I can't spell Q. Okay, so so let's see. Q. Okay, so I don't know. How did I spell it? Q U E U E? Yeah, Q U. Okay, so this is your Q broker in here. And basically, we went and said, okay, some client, some customer somewhere is going to put a message on that queue, given that, ideally in the real world, we put something like a trusted source. And this trusted source will basically tell us, oh, this is a trusted source. We need to verify the keys, and your secrets cannot just be, it's like a zero trust kind of pattern. Okay. And your queue here and your storage here, the message comes from your queue. This is some client, and they're putting the message on the queue. The event goes all the way up to the student event orchestration service like this. And then it picks up the message, and then it puts it in the database. So this way, you're only you're event based. You're only corresponding to particular events that are happening in your system. As such, how you want to design and architect event-driven systems, that's how you're going to do it, right? But let's just throw that example in there just to see how people going to think about it. Maybe your student event orchestration service is not enough, and you have a whole other slew of capabilities that you want to add to this situation. So let's say you have another storage in here. It could be the same storage, it could be a different storage, it doesn't matter. I'm going to take this exact design here and I'm going to just expand it a little bit. So I'm going to go here and say, okay, instead of, I want this event to trigger more than just adding a student in a database. So I have all these storages, but now I have a library account storage broker, and I have a library card storage broker, like this. And then you have services, that's library account service, and you have a library card service, and this is your library orchestration service. So look how this orchestration service wants to sit and also listen in on these events that are coming from the queue. So the queue message is coming in, we create a student account, and then we go talk to the library orchestration service and tell the library orchestration service, hey, I want to also create a library card and a library account for that student. A student can have multiple library cards. They can only have one library account, right? And I'm going to go up in here and add what I call a coordination service. So now you're going up a level in your complexity, and you're going and saying, okay, I need a student event coordination service. And this coordination service, after the persistence happens on the student level, I want to go and do other things underneath that. You can add multiple other things, like you want to go and add, maybe locker room and maybe sports room and all the little business flows that you want to actually append to an existing flow that you have. How do we go implement that? And why am I talking to you about that? Number one, this is a real world scenario. You're going to need that stuff, right? Like what I taught you last time about the cul-de-sac is great, but that's great only within a very specific realm of implementation, right? But if you're building an end-to-end enterprise level system, sometimes you have multiple flows that are relying on this one message that's coming in, right? A lot of people have asked me before, I said, what happens if one thing fails? We're going to talk about the rollback and role commits, and what does that mean, and how do we abstract that rollback so it's not really attached to a particular technology. Story for another day. Don't worry about that now. Assume that it's all bunnies and rainbows out there, and assume that we are, that everything is just going to work fine for now. Of course, we're going to have validation, exception handling, and reactionary, programming to any particular event that happens in your system. But just imagine this scenario here, right? We have this problem here that we need to solve. And now our previous implementation or our previous architecture doesn't work anymore, because this coordination service wants to be able to pass in additional capabilities where it's able to actually pass in a library request of some kind and be able to process that student library request through an orchestration service that will go and actually create a student account and create a library card for that said student. How do we go about doing something like that, right? Let's go back to Visual Studio real quick and see what we can do. Let's start from the bottom, right? Let's go from the models, and then from the models we'll build our way up into foundation services, and then we will catch up to an orchestration service, and we will test our orchestration service, make sure that it actually works, maybe expose a controller or something, and then we will do the attachment at the very end. This is not a simple tutorial, and it's very advanced engineering topic. So, get your notes ready and get ready, because this is going to be really important. Okay, let's start with the models. What do I want? I want a library account. So I'm going to go here and say library accounts, because this is a namespace and a folder. And I'm going to go here and say, okay, I want to create a library account model. Let's go here. Here we go. Here we go. And then I'm going to go here and say library account. That's my library account. And my library account, has two interesting things, right? The first thing, it has its own ID. So that's an ID. That's cool. That's the library account ID. But it also has the student ID. So this guy here is going to be student ID. And in case we want to pull the student in, how we're going to set up our student, we're going to talk about that in a second. So this is student, and then here is the student that's attached to this. Because these two are together, I normally just separate them like this for just readability. Later on, we're going to add library cards, which can be many library cards attached to one library account. Okay, so that's the model. Great. Now what? We want to go build the storage broker, right? So I'm going to go here and under storages, and I go and say, okay, let me create a simple interface, and I call this storage broker dot library accounts.cs. All right, so that's my guy. And then I'm going to make this partial. And I'm not going to implement anything yet because I still need to create the migrations, right? We were talking about this the other day with Yasser on the Vazar project. We'll do the same thing in here. So let's go here and create a quick concrete class. Here we go. So this is storage broker dot library accounts .cs. Here we go. And this guy is partial again because we got all the storage broker stuff underneath one umbrella. And then I'm going to go here and say, oh, we have a DB set like this, and this DB set has library account in it like that. And then here is my library accounts. Is this the end? No, not really. We still have to build the relationship between a student and a library account, right? And maybe the student used to have a library account that got disabled, or whatever the case may be. This is your library account situation. So what are we going to do now? This is another concept that I'm really excited to show you here. And let me take away the camera so you can just see the solution here. I'm going to go here and type this. I'm going to go and say, okay, give me something called storage broker.library accounts.references.cs. So this guy will nest right under this guy. Why references? Because we want to build the relationship between the student and the library card or the library account, right? So how are we going to do this? I'm going to go here and say private static void add library accounts references like this, and then I'm going to go here and say model builder. And this model builder is the one that comes from the Entity Framework. And this is the guy that helps me kind of set up the relationships. I use the Fluent API when I build these things because your model is supposed to be anemic, right? You'll see some folks go here and they say, oh, this is key, and this is foreign, and this is, oh, this is required, and all that. Don't do that. That's really, really bad because your model now is not anemic anymore. Your model now is having business logic in it. And how are you going to test that, for God's sake? So that's not going to work. Let's not follow that pattern. It's not a good pattern. So let's just go back to this guy here. And I'm going to say here's my builder. Let's call it model builder like normal people. So here's model builder. Here you go. And then here is model builder dot. Right? And then in here, I want to go and say for this entity that I'm working with, which is an account, library account, this guy here, right? I can go here and say has, right? Has has one. Let's see, has one, right? And that's your library account dot student ID, right? With many, right? And this is now the student. Oh, wait, this is student, like this, student. So I'm setting up the relationship here. And then this student will have multiple library accounts. We don't have that yet. We'll add it to the model. While we're at it, let's add it to the model real quick. I'm going to go here and say I collection, I think, or I enumerable. I enumerable work better. So let's do I enumerable. There you go. Public I enumerable of library accounts. And let's call this library accounts like this. right? And let's just pull in the references. Okay, so this is my relationship that I'm building here. And then in here has foreign key. So now I'm working with, again, with the library account. So this library account, like this, library account dot student ID, right? And then if you don't want, if you really don't care about adding the, the capability of doing a reference delete, like if you delete a student, you delete all the little details underneath. Usually, what I do, and I go and say undelete, right? Delete behavior, ignore, or something like no action, something like that, and that would be it. So where's this function going to go? This is just me building the relationship between one student and multiple library accounts. And every library account could have multiple library cards, right? It's just one library card and that's it. So how is this? Let's say, you know what? I changed my mind. Instead of having multiple library cards, let's just give the student one library card because I think, sorry, one library account because this is a little bit of an overkill. Let's just say one student, one library account, and that's it. So instead of with many, it'll be with one, like this, with one library account, and then in here we can go and say has foreign key library account dot student ID. What's the type on this guy? Library account. I guess it doesn't need that. It doesn't care. It knows what to do. Great. Magic. Okay. Now, where do I put this guy? This guy goes into the node file that you have here, and you can go here and say override. And on model creating, you can go here and say add library account references, and you just pass the model builder to it. So model builder like this, and we're done. Since this is a one-liner function, I'm just going to go here and say, okay, this is my one-liner function right here, and we're done. So one student, one library account, done and done. So we built that relationship in here. Great. Now let's run the migrations, right? We did the model, we did the relationship. Let's run the migration. First of all, let's just make sure everything builds like normal. And make sure your tests are passing. When you're generating random data and you add new models like this, it could get in a, cyclic situation. So, okay, this is all good. Now let's go and generate stuff. Let's go here and say add migration, add library account. Boom. Let's see how that guy works. Here we go. Boom. What did it generate for me? It went and said, okay, here you have a table called library accounts, right? And this guy is attached to some student, an ID and a student ID. And this is a unique qualifier. And then my foreign key is the student ID. I love the entity framework. It's just magic. It's just pure magic. If you want to see if this actually really works, if you open up the SQL Server object and you open up the SQL Server and you go into, what did we call this project? Cul-De-Sac. Here, Cul-De-Sac DB. And if you open up your table and did it not execute the migration yet, or do I need to refresh? Let's see. Yeah, okay. Let me kick off the migration. Update database. Let's go. Okay, let me refresh this guy. Here's your library accounts. If I expand, let's just open the designer for this guy. So if you view the designer, here we go. Look at this guy. It goes and says, okay, you have library account student ID that references the ID on the student table. Magic, just works, right? So when you pull a student, it gives you the library account with it. If you want to expand, if you're using OData or whatever, this guy is done, right? Let's make a commit here, just for funsies. Actually, I'm going to put this in a different branch so people know there's a difference. Okay, users, Hassan, Habib, let's say data. Well, I'm going to do the whole thing, so I'm just going to make it feature advanced cul-de-sac. Okay, so let's go here and just start with this data, add library account model and migration. Okay, so that's one. All right, now what? We need a storage broker, right? We need a way we can insert, these library accounts into a database. So I'm going to go back to the same interface that I have, and I'm just going to go here and say, well, I want a value task. Zoom in a little bit for people. And then here's your library card. Library account. And this is insert library account async, and it will take a library account and it will persist it in the database. Remember, this guy has a dependency on library account. It has a dependency on the student. So a student has to exist before we can actually pass that ID downstream. So the sequence here is very, very, very intentional. And this is a very advanced engineering topic. So just, stay with me. This is really, really important. Okay, so let's go down here and implement this. So public async value task. Value task is much faster than task. Really important for people that ask me that question. Here's library account, and then insert library account async. Takes in a library account thanks to the AI doing my job here. And then let's go and say using var broker equal new storage broker, because I don't like the whole let me do the work for you on the entity framework side. So I'm going to do it this way. And then I'm going to go here and say this is entity entry. That's what this guy generates. And it takes a library account and then a library account entity entry. Looks like we need a new line here. And then await this dot, not this dot, await broker dot add library accounts dot add, and then or add async. And let's add this new library account to it. So that's done. And then let's save our changes. So broker.save changes async. This is own instance. And then at the very end, I'm going to go return the library account library account entity entry dot entity. So this is the implementation of just inserting data in the database, right? Sweet and simple, 30 seconds, you're done. Okay. Let's just build and make sure things are in good shape. We didn't forget anything. And then let's go here and submit this as broker or brokers. And then you can say insert library account capability. So this guy here is committed. We're good. Let's go build a foundation service, right? This is super quick. I'm not doing validations. I'm not doing anything. I'm just going and saying just happy path end to end. Let's see this thing through. And then if you're following my videos on my engineering standard guidelines, you know that this is really just a very bare bone kind of capabilities that we're building here. All right, let's jump to the services part. So here's the service part. Let's take away my face here, and then let's go into the foundation. So under foundation services, I want to go here and say I want to create library accounts. And then here's my interface. So this will be library account service. And this library account service, all that it's going to do is really just going to offer a capability where I can add a library account based on particular elements. So this is library account. And then add library account async. Take that guy. Here's this guy. Here's my interface. Let's go and add in the actual concrete class, so library account service. And then let's go here and make this implement the interface, library account service. And then this guy will need a private read-only storage broker. That's really all that we care about at this moment, just so we can implement that. And then here's my storage broker, CTOR, actually not even CTOR. If you select your private class members like this and do this, it'll just generate the constructor. So like I always tell people, the less you touch your mouse, the less you touch the mouse while you're working, the more likely you are to get, stuff done as fast as possible. So do that. Do learn about the shortcuts of Visual Studio so you can actually, deliver faster value in shorter time. A lot of people say, hey, Hassan, how can you do all this work so fast? Here you go. Life hacks, extend what you can do in one period of time. Okay. So add account, I need a unit test, right? Even if this is a POC, I'm still gonna write unit tests just to, for people that are watching us to understand, how you can develop these things. So I'm gonna go here and gonna go and say, here is my folder, and then here's library accounts. And under library accounts, we can go and say, I need a base or root file for library account service tests. So that's my guy here. I'm going to partialize that guy because there's a place where you prepare the code and there's a place where you actually start testing the code. So here's private, read-only, mock, storage broker. There we go. Storage broker, real quick. And this storage broker basically goes and says, I want to storage broker mock. And the service that I'm actually testing is library account service. This guy too. And here's your library account service. Like this. So now here's my constructor. I can now go and say this is your storage broker mock new. Come on, there he is. Just writing it for me. And then this dot my service library account service will equal new library account service. And this guy will take in a storage broker as an input parameter through dependency injection, and we will pass it the object, and all good and dandy. The last thing I want to do is just create just a random library account, right? And we use something called object filler. So here is filler. It generates a random one, so we can't actually fool the tests and make our own object internally. You'll see a lot of people hard code the values in their test. That's really bad. Don't do that, because now it's a lot easier to kind of find a loophole into your, think about a unit test and your function as like kind of, two opposite sides, and each one of them trying to find a hole, into the fortress of the other. So you want to really protect yourself from the business logic perspective against the randomization of tests, and from a test perspective against the, the potential loopholes that you can find in your implementation. So okay, so here's library account. That's your guy. Come on. Here you go. And then create library account filler. Perfect. And this guy's going to be simple. We're just going to go here and say, hey, new filler library account, because we don't have really date times or anything special, so we can just do this way. And then in here, I can just go and say private static library account, create random library account. I repeat that stuff a lot so people kind of actually get a hold of it, so you should understand, this is how you're supposed to build these systems, and this is how these systems are going to look like, and all that. Okay, so that's one part. Now let's go build the other part, which is the actual tests, right? So let's go here. Let's go into the .logic.add. So a very particular test that I'm going for here. And it's going to test the add capability in my library account. Let's do that. Here is a fact. And then public async task should add library account given when then. Some people use assert arrange action or whatever. That's okay too. Given when then is more understandable between the people who write software and people who ask for the software. If you go and say assert arrange and that kind of stuff, they don't understand it. They'll be like, what's assert? What does that mean? But if you kind of narrow your language between the business folks and the engineering folks, together, it makes things a lot easier. So when they write a user story, it actually makes a lot of sense. And this is really, really important that you kind of understand that part. Okay, let's create a library account. This is random library account. Create random library account. Here we go. If your lines of code are going above, like normally 120 is the hard rule. Like I'm gonna stop your PR if you put a line of code that's over 120 characters, because as you can see here, if I go all the way up to here, see even that, like this is 120. This here, all the way up to here, that's 120 characters. For someone on their laptop, like normally I code like this. Like this is my view, right? So for someone on a laptop, that's the maximum they can do. If your lines extend beyond that, that's just the code becomes irritating. It becomes unreadable. So you want to probably keep that rule handy. But also the other most important thing is that, okay, what if your line is not 120 characters, but it goes beyond your definition of your method? Normally I just break it down. I keep it all, like I don't let it have a pudge, like it doesn't have a billy hanging, in your method. I just kind of keep it a little bit, in shape. Keep your method in shape. So I'm just gonna go down here and say, okay, library account, input library account, and this guy is gonna be coming from the random library account, and then the library account here. See, I have the same variable, but I'm giving it a different name based on the context that you're working with, right? So this here is inserted library account, and that would be from the input library account. And then the last one is the expected library account. Expected library account, and this guy will be inserted library account dot deep clone, like this. So why we're deep cloning this? Because the method can't play around based on the reference with the data that's coming back. Now let's just mock. Let's set up our mock. So this is your storage broker dot setup. So here's your broker.insert library account async. Here's your input library account, and then this guy returns asynchronously. Returns async. We need mock here, and then this is inserted library account. Okay, perfect. So that's the setup. Now the last thing I want to do is that I want to go here and say library account actual. We did the expected, so it's the actual now. Library account await this dot service, add library account async, and this is your input library account, like this. Okay, so I have all of those here. Now what's next? The next thing is that I want to compare this actual library account to my expected, be equivalent to expected library account. Perfect. What else? I want to verify that my storage broker mock has actually been called with this particular library account one time. Done. What else? The last thing I want to do, I just want to verify no other calls have happened to this mock, so that my business logic is not doing any trickery there and trying to kind of play around with the capacity of using my dependency more than one time. This is a solid test. This here is a solid test that will make sure that nothing goes through except what you intend for it, to happen. And some people, just so you guys understand, some people will tell you the test is not supposed to, basically, they're not supposed to, your test is not supposed to tell you how to implement, the code, but it only cares about the result that comes from the other side, right? And that's one argument some people talk about a lot. Like some people will say, my unit test should not dictate how the implementation should happen. It should only tell me, that the input should be X and the output should be Y, and that's it. That's all my unit tests should care about. That's wrong. That's really, really wrong. And I'll tell you why. There are actually three kinds of tests. There's unit tests, there's acceptance tests, and there's integration tests. I agree with you that the acceptance test and integration test does not dictate what you really need to do within your functionality to implement a particular capability. I agreed, no problem. But your unit test, it really is testing a unit of work. And it's making sure that there are no side effects, no things happening on the side, in your system that can actually take down your application. Let me help you understand. If I'm building a method like this, and I'm going and saying, okay, I'm not going to verify this guy. I'm going to keep this guy like this. I'm not going to touch it. Right? What that basically means is that I can literally go in here and go and do an infinite loop, or just do a loop in here like this. By the way, this is how you can do an infinite loop in C#. One way, other than the while true, you can do an infinite loop like this. There you go. You learned a new thing. Hopefully, that made you smile a little bit, right? you can go like this, and I can literally go and say, I don't know, this dot storage broker dot insert library, and I'm gonna add my own library card in here. I'm gonna storm your database with junk data that you won't be able to handle, right? And eventually at some point in time, I don't know, maybe after 1000 iteration, int I equals 0 and I didn't write this in a very long time. And like this, maybe at some point in time, I'll go at the very end and tell you, oh, here's your library card, no problem. If your unit test can't catch something crazy like this, then it's not a unit test anymore. It's not doing the right thing anymore. So at the level of the unit test, yeah, you're putting your method under the magnifier, and you're making sure that your unit tests is actually making sure that there are no side effects that are happening in your system that could damage your system internally. If your unit tests can't protect your business logic, then they're not tests anymore. All right, so there's that part here, and then okay, so that's great. So okay, so we have a failing test here, and let's go into the tests here real quick. Let's run this real quick here. Here we go. This guy's supposed to fail because that's how test-driven development works. Come on, come on. There you go. So this guy's failing. Okay, I'm gonna go and make a nice commit here, and I'm gonna go and say, okay, this guy has failed. Here's a fail. Now let's make this pass, right? So I'm gonna go back into my library account. Oops, I made this by mistake. Let's put this back, and then let's go here and say, okay, in my add library account, I'm just gonna go here and say, okay, it's really simple. Let's minimize this guy. Let's go and say await this dot storage broker dot insert library card, and it's library account, and here's your library account. No validation, nothing, because it's just happy path. No problem there. All right, so far so good, no problem. Let's run our tests. Here we go. Done. So your test is passing, everything is happy, no problem. And we should call this async, by the way, because it's asynchronous. Okay, let's go there, this, and there's your library account, and then let's go and say pass. Okay, so that finishes up this part in here. So let's see, this is done, 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 kinda done. All of this is done here. Just a second, green. All of these are done. This guy's done too. This guy is subject for modification, and I'll tell you what we're gonna do with it in a second. And then we have this guy and the library account here. These two are done, the storage broker, and we finished the service as well. Okay? Let's do the same thing with the library card. The library card is a little bit different, right? You can have one account that has many, many, many library cards underneath it. I'm going to keep the model super simple so you don't have to worry about the little details. We don't care about the little details. We just want to make a proof of concept. This is my version of a proof of concept, a 2 or 3 hour video and a tons of code that shows you how that works. Okay, let's go back to our models again. And now I want to create something called library account. Library card. So let's go here and let's say library cards, because it's plural, it's a namespace. And then let's go into this guy here. So this is library card. Great. And the library card now is a little bit different because it also has its own ID. So that's an ID. But it also has a reference, and this is one-to-many relationship, like many library cards to one account, because you could have your library card missing, like you forgot your library card or something, right? So now you could have multiple library cards against the same library account against the same student. I hope you can see the model here, okay? So this is here is the library account ID. Look at that. And what that means is that I need to kind of attach the actual model to it. So this is your library account. So when I pull data, I can pull data from multiple places. And this is my library account. That will require a little tiny change to my library account model. Now I'm going to have to go here and say, oh, wait a second. Now we have an IEnumerable of library cards. So one library account has multiple library cards. One student has one library account. Library cards. Done and done. Okay, same thing. Just gonna go create a model, have the model do the little magic with the, entity framework, generate the model. Beautiful. Just the entity framework. I'm building an entire enterprise system for POC as fast as this. It's been like 34 minutes, 39 minutes, in addition to me talking for at least 90% of the time and coding just 10% of the time. So that should give you something. Okay, let's go create an interface for a storage broker. There we go. This is interface, storage broker. This is exactly the same thing that I just did a second ago. Storage broker dot library cards dot cs. Okay, this guy is good. Let's give this guy a partialization. No implementation, not just yet. We're gonna add an insert library card in a second. And then I need to add the concrete class. So I'm gonna go here and say, give me concrete class. So here's my storage broker dot library cards dot cs, library cards dot cs. Yeah, perfect. And then we need the db set. So let's go here and say prop db set. I was pairing with someone once and they forgot to make this guy public. They made this guy private. And we spun, we were like a chicken with its head cut off, just running around in circles, trying to figure out what on God's green earth has happened until I found this being private, and it wasn't working because of that. Or I think he defined this as private without a getter and setter. Yeah. It was something like this, private, and then it was like library cards like this, and then he just left it like this. And we kept going in circles, man. It was crazy, right? Until we figured out, we spotted it. Some of these things makes you like question your sanity. Be like, I'm done with this. I'm gonna go work as a greeter at Walmart. That's it. Software engineering is not for me. Okay, so we figured it out. So something for you in case you run into this situation. I hope not. You know that there's a possibility that someone's gonna throw a private without a getter and setter in there, and things are gonna get really, really icky. Okay, so this is a library card. Let's go create a references piece here. So I'm gonna go here and do this, and then I'm gonna go say storage broker dot library cards dot references dot cs. Okay, and I'm gonna do exactly the same thing, except that this time I'm gonna even steal this one just for the with respect to time and all that. I'm just gonna throw that in here and say add references for library cards. Okay, now the situation is a little bit different. Instead of a library account, I want to do a library card. And instead of one with one, like instead of one-to-one relationship, I'm going to make this one-to-many. So let's see how that looks like. So every account, I'm going to call it a card. Except that this library card has one library account. And this library account has many with many. So this is your account here. You could call it library account too. It's up to you. With many what? With many library cards like this. And then with foreign key, what's my foreign key now? So this is the library card dot library account ID. We need the ID here because this is a one-to-many relationship. So the situation here is a little bit different. How does the entity framework does it underneath? If you saw my session with Yasser, a couple of days ago, you can generate SQL easily just to see how does it actually translate that to. No problem there. One more thing. We need now this guy is not a thin arrow anymore because we need to add library cards references, and it's nice if you make it in that particular order so people who come and read your code know, oh, the library accounts go first and then the library cards and then whatever else comes underneath that. Right? Library accounts becomes a secondary entity, and library cards become also a secondary entity. So a secondary of a secondary entity. Okay, so we have two secondary entities and then one primary, which is the student. Okay, let's generate migration. Let's go do that again. So let's go here and say add migrations, and then add library cards. Let's generate migration. Let's see. Here we go. Boom. It generated the migration. Has foreign key to the library account ID. Just beauty, just music. This is why it's called C sharp. C sharp is a musical note. I'm not really big on music, but I can see the flow of which the system is running. Let's update the database real quick and check our models are doing the right things. There we go. And then let's go back to SQL, refresh our cul-de-sac library, and then let's look at the library cards from a design perspective. Not the data. I always click the data one by mistake. Let's go to the designer here. Check it out. Look at this. So it has, library cards, library account. It's attaching this to that, and this is your foreign key. Just beauty. Just beauty. I wonder if I can show you this structure actually in SQL Studio. SQL Studio does that magic for you. You can go and create. I wish at some point in time Visual Studio, would add this capability, like all one-stop shop for all things development, since we're using ORMs and we're not touching databases anymore, and we're controlling that through C sharp. It would be nice if I could just do the same thing from here. So if you're somewhere on the VS team, Visual Studio team, SQL team, get together and have some coffee. I'll buy you the coffee and just make it happen. Okay, guys? Okay, let's go back here. Let me just log in into my local database here, and let's see if I can visualize that for you. That I probably will be able to. Let's see. What's it called? Cul-de-sac, cul-de-sac DB, and then tables, database diagram. So I'm gonna create a new database diagram. Yes, of course. And then let's add all these nice tables that we have. So we have a library account and a library card and a student. And I'm going to close this and watch this magic. Look at this. This is really beautiful. It's basically telling you here, this is literally the model that we built just right now. You have a library account. There's one-to-one relationship between a student and a library account, right? And then between your library account and your library cards, there is a one-to-many relationship. How beautiful is that? Isn't programming beautiful? Most beautiful thing ever, right? What is this nonsense? Solution Explorer. Oh, nice. Okay. Can I add stuff in here? Oh, yes, I can. I heard, just word on the street, that you can actually write unit tests for a database. Please don't do that. I don't know what you're going to do with that, but I haven't tried it. Maybe I'll try it in a video. Who knows? Okay, so we built the right models. Let's go and write a commit here and just say data, add library card model, and migration. What else? We need a storage broker, right? So let's go back to our storage broker for library cards interface. And I'm going to go here and do exactly the same thing. So value task, let's see. Value task. And here's a library card. Excuse me. And here is insert library card async. Here's your library card. Great. And then let's go into the library card implementation, and let's go and say public async value task, library card, insert library card async. There's your library card variable. The exact same thing, just like we did in the previous one, excuse me, using var broker equal new storage broker, the safest way you can do this. And then entity entry, there we go. I like how Visual Studio so you see what just happened here? Visual Studio actually fixed the spelling. Like, this is not English, right? So Visual Studio will go, if you do control period, it'll be like, okay, there's a lot of nonsense. Maybe you want me to generate a property, or maybe you human don't know how to spell things, and I'm gonna fix it for you. How beautiful is that, right? Back in the ye olden days, you couldn't do none of that stuff, right? So today you have the world in your, in your hands. You can just do whatever you want to do. So entity entry, library card. Oh, it's library card, okay, library card, entity entry, and then await broker dot insert library card async, and then pass the library card to it. Call it a day. Oh, wait. Oh my God. Okay, wait a second. So let's go back here and say library cards dot add async. Sorry about that. And then await broker dot save changes async, because why not? And then return library card entity entry dot entity. I usually like to make everything asynchronous. If you can make everything asynchronous, it's not always an option, But if you can make everything asynchronous, please definitely do. Okay, so we have this thing in here. That's great. You know, let's go ahead and commit that. So let's go here and say broker, insert library card. Now what? Now we need to build a foundation. So let's just go back on the map and define what we just did. We did these two pieces here. When I refer to this database, that basically means I have created the model and migration. Because just by creating the model and migration, you already created a database table, and that's what this means, right? From an architecture, high-level architecture design standpoint, like up here, you will see sometimes that we'll do something like this. And this here doesn't mean that I have multiple tables. This here means I have geo-redundant instances of the same database, or I actually did break all my entities into their own databases and database storages and servers, and I'm actually distributing and doing something crazy across multi-billion, record, million transactions per day and something like that. And we will talk about these things. I'm going to share all that good stuff with you. Time and pressure, right? Patience and prayers. We'll get there. Now let's build this guy, right? This guy here needs a little bit of work, right? Because we need another foundation service that abstracts away, our core business logic interaction with these services, right? So let's go back here and build that service real quick. Let's go back here. Here's your storages, brokers. Let's go into our services under foundations. Nice. We're going to build a coordination service today. Should be excited, right? So library cards. And then under these library cards, I'm going to build an interface real quick. So here's my interface. I library card service. And I also want my library card service, which is this guy. This is a concrete class that is library card service, like this, right? And then in here, I'm going to go and say value task. Here's my library card. Add library card async. And here's your library card, and it's writing the code for you. Great. It's not library cards though, it's just one library card. Perfect. Right? See, the structure of your solution is super important. It will help you when you have 50 million entities and you want to break them into microservices and all that. It's also simple and easy to understand for anybody. Now let's just go and implement this guy. So this is iLibraryCard service. Here's this guy, and then I need a private read-only iStorage broker. See, even when you mistype it or misspell it, it'll help you. Man, we're in good times. Engineers are in good hands. Here you go. Generate the CTOR constructor, and then let's go down here and say this is my. Okay, so this is a service. Let's go write a test for it. So under foundation services, I'm going to go and create a library cards folder. I'm going to copy these two since I showed it to you already in this video. I will take the liberty into changing library account into library card. I'm not going to change the name now just yet because Visual Studio does this nasty thing with changing it across the board, which is not exactly what I want to do. And then I'm going to do here a quick find and replace. So in here, I'm going to go and say honor the state. And every time you find library account, change it with library card and replace. And then let's replace for variables as well because of the service. So this is library account. Replace it with library card. Donezo. Great. So that I got my test here. I got my namespaces, everything is done right. Love it. Love it. Just take another quick look just to make sure. Let's do the same thing here, right? So you can get historical stuff like, so library account turns into library card, replace that, done. And then library account uppercase, replaced with library card uppercase, replace that, done. Wow, 26, interesting. So there you go. Library cards, it's gonna hit your library card service, insert library card. I wrote the test for you in like 2 seconds. Right? It's worth it because it's going to help protect your system. So let's run this. Let's let's go. Here you go. Here's a failing test. That's good. Failing test is good. This is a good failure. It's basically saying not implemented exception. So that means actually truly that what's driving your implementation is the failing test. All right, so far so good. Let's go implement that test, which is going to take a second. See, when you do something over and over and over again, you know, becomes like you can talk while you're building the code. Like normally when I'm pairing with people at this point in time, I'm not really writing, I'm just chatting with people because this is already happening in real time. Your brain is already, you own this as a second nature. And if you get yourself accustomed to an engineering standard and a way you build software, you won't feel like you're writing software anymore. You'll only need to engage your brain only when you need to, when there's something specific, like I'm going to show you in a little bit. Right? It makes software engineering a lot less stressful and a lot more enjoyable, and it helps you kind of get closer to your team and work with the people that you're working with without any issues. All right, so add library card, give me a green. Here's a green. Great. That takes care of the foundation service. Again, like I said, this is a very, very basic implementation. In the real world, I put a lot of validations and stuff like that. Okay, so this guy's done. Let's get to this funny guy here. This is a library orchestration service. The library orchestration service will do what? It will get, excuse me, it will take, you know, a student or a library request, and it will turn that library request into a library account, and it will turn it into a library card record. So it'll create both of these for you. You know, it will convert it into models that you understand. And that's what I call a virtual model. Like you don't actually persist this in the system. You're not doing anything with that. All that you're doing is that you're just going and saying, you know, create this for that particular student. Create this for a particular student ID, right? So how is this going to look like? Since this particular implementation here doesn't really care about returning anything, you know, we can just implement a library that basically goes and says, hey, create a library account and a library card for this student. And I don't want anything else from you. This is all I really care about from an implementation perspective. Can we do it this way? Let's go and do that. So this is an orchestration service here. I'm going to go down here and say, okay, let's start from the model. What kind of model do I want to pass? Because this is a very simple scenario, under the orchestration services, so here's your models. I didn't create, yeah, because we didn't have the chance, but okay, orchestrations. All of these models need to go under foundations, that's okay. And then I'm going to create another folder here, and this folder is going to be called library request, right? Library account request, like this. Or do we just give it the library account and that's all? I think that works too. I'm okay with that as well. You know, that could potentially work. If we want to, let's do it this way. Let's keep it simple for people here. Here. I can go here and say, okay, fine. You know, I'm gonna create, here's your foundation services. I'm gonna create, see, this is the part where you start thinking, right? So okay, library accounts. And I'm going to create a library account orchestration service. So let's go and create that guy. Here we go. library account orchestration service. I wanted to show you the virtual model, but it doesn't seem like a good scenario. So let's just keep it this way. Okay, fine. Library account orchestration service like this. And my orchestration service has two dependencies. That's why it's orchestration. It does two things. So I'm going to go here and say value task. And the language here may change a little bit. You know, like instead of add an account, you're saying, oh, create an account. You know, or register an account. Whatever language you want to use, I'm okay with that. So here's a library account. And this guy will take in, you know, create a library account async. I'm okay if you do it this way. There is my orchestration service. And then in the implementation side, here's iLibrary account orchestration service. Put the implementation, done and done, beautiful. Okay. What else? We have some dependencies, right? So we have private read-only iLibrary account service. So this is the first dependency, right? Because you're doing orchestration. Library account service, here's one. And here's another one, iLibraryCard service. So these are the two services that you're orchestrating together. Is LibraryCard service, like this. And then let's go and create a CTOR. This time we need the scope, except that it doesn't understand that this is too long. So we're gonna have to break it, into two input parameters. All right, what do we need? We need a unit test, right? This orchestration service is going to create two things. It's going to go and create a library account, and then out of that response, it's going to map it to a library card, and it will pass that library card downstream to whatever service it's working with. Right, so there's a lot of interesting things to learn about there in terms of implementation and all that. If you control the library account that's coming back, you already control all the details about what you really are trying to pass in. All right, so let's do that. Let's write a test real quick. So let's go here and go under orchestrations, and let's create a new folder, and this folder is called library accounts, like this. Okay, and under these library accounts, I want to create a test. So he says library account orchestration service tests. Okay, let's go here, and this is my public partial, like this, and here's private read-only mock iLibrary account service. This is the first mock that I want to do. Here we go, and this guy is library account service mock. That's one guy, and then I want another guy here, which is instead of library account, it'll be library card service. Library card service mock, like this. Okay, done. Great. What else? I want the service. So iLibrary account orchestration service. There's my service right here. Library account orchestration service right here. And let's do a CTOR. Let's go here and initialize all these nice guys. Library account service. The order here is really important because you will call the library account service first before you actually call the library card. And I'm going to show you how you can verify that. So it's a real nice trick that you can see here that shows you the whole thing. So here's new mock. Let's go. Done. Let's go. Okay, there you go. And then this .service, which is the orchestration service. And that's your library account orchestration service that takes in the library account service, this library account service mock the object, and it also takes a library account library card service mock, which is this library card service mock object. There you go. I misspelled service here, so let's fix that. Service. Like this. Okay, so this is the initialization of this simple, it's really simple orchestration service. Go create one record and then create the other. Done and done. There's no magic there. Right? Let's create the request that's coming in, right? So I want to go here and say, well, I want to a private, let's go do this. Private static filler is my filler, and then here's your library account. That's the request that I'm going to be passing in downstream to this guy. So create library account filler. New filler, library account, done. Okay, and now let's create a random one. So private static library account, create random library account. Create library account filler, dot create. That's the second one. Let's start with this one in terms of testing, right? What are we going to do with this one in terms of testing? I want to go and write a test in here. Did I partialize this guy? Yes, I did. Let's go and paste this in here. And and let's go here and say this is just a normal create. So logic.create. So let me take away the camera here. So this is this logic.create at this level here. And this is just a copy of this original guy. So I'm just going to throw away all of this and I'm just going to write my own test. Here we go. Fact. Public async task should create library account async, because that's what this method is trying to say. This is what I'm going to do. Given when then, great. And then here's your library account, random library account equal create random library account. We just created that guy, right? And we also want to go and say, this is my library account input library account. That's coming from random library account. Here we go. And then here's another library account, which is your added library account. Great, that's your input library account. And then the last one in here is the expected library account, which is the added one. Deep clone it. Deep clone that guy. Here we go. This guy has a little bit of a billy, so let's break that a little bit further. Let's make our stuff clean and clear. Even if it's POC, you never know. Your POC might end up in production and you might not have a lot of control over it. So, you know, piece of advice from your older brother here, 21 years doing this, even if it's a POC, just make sure it has some sense to it. It might end up being someone else's nightmare to maintain and keep. All right, let's go here and say this dot. Here's my service mock setup. And here's a service, and this service is going and saying service.add library. Let's see, add library account async with your input library account. Beautiful. And this guy returns asynchronously the added library account. Great, thank you, computer. It's figuring out everything on its own. Great. Now, I expect two things. My expectation here is that I have a library account. This is my actual library account. And I'm going to go here and say await this.service. This is my library account orchestration service. And underneath that guy, I want to go and say create library account async. Easy peasy. You can go and say actual library account should be, then pull the references here, should be equivalent to expected library account, like this. Okay, great. This is so far so good. I also want to verify that the library account service mock has been called the right way. So that's your service dot add library account service with input library account. So far so good. And this guy was called times once. Great, love it. Now what else is left? What's left here is that I want to verify that that I called the LibraryCard service after I've created the account. So I've created the account. I want to ensure that I also created the service that created the card itself. And that's the part of orchestration that really matters the most, right? If I'm just creating a library account, why don't I just call the foundation service and call it a day? So that means I want to go here and say LibraryCard service mock.verify, watch this, that this LibraryCard was called at least once with any object that has the right stuff in it, the right details in it. Right? What are these right details? These details are the details that tell me that I actually captured, you know, what was passed into that system at a point in time. Right? Which means that this entity that needs to be passed in need to have the library account ID as a foreign key into that model. So we're going to do something a little bit different. We're going to go and say it is, you might have seen this before, same, it is same library card as, and I'm going to go here and say expected input library card. So my input library card is something that I am trying to make sure that it was actually having certain parameters. I don't care about its ID. I care more about having the library account ID in it. And I want to make sure that this guy got called exactly once. So what does this same library card as look like? Let's go back here. Let's go here and say private static library card, expression of a func of that takes in a library card as input and returns a boolean. Same library card as. And this guy will take in a library card as expected library card. This is expected versus actual situation. And this guy will return an actual library card. How long is this guy, by the way? This is 110. Okay, right there. Actual library card. The only thing I want to care about is that the actual library card dot library account ID equals expected library card account ID. That's the only thing I really care about for now. We will make this a little bit complicated later. I just want to know that whatever my orchestration service have generated has the value that the library card account ID matches the same account ID. Now, where's that expected guy? Where do I get that expected guy from? I'm going to go back here and say, well, here is your library card. And this is your expected input library card. And this expected input library card must have whatever random ID that is coming from this library account. So I'm going here and saying this is my library card. I don't care what you're doing with. This is going to be a var because the right side is very clear. Push that guy up by 1. Control KD. Clean things up. Here's your ID. Don't care what your ID is. Like this. But the library account ID has to match the input, actually the added library account dot ID. These IDs have to match 100%. Okay, what that basically means, I can pass this guy down here. Okay, this guy's already passed. Perfect. Now I just need to verify that my dependencies are in good shape. So this is my mock, verify no other calls in the exact same order. And here's another mock. I'm not done yet, but there will be a lot of good stuff coming your way. So this is a test here. See how orchestration services require you to think a little bit. It's not as straightforward as a foundation service. Sometimes it's just really easy. Just call this service and call this service when they don't really care about the dependency of one part, being part of the other. That happens. Let's run the test. Our hypothesis is that we need to receive a not implemented exception. Control KE will clean up the junk, the stuff that we don't need. Here's the failing test, and it's saying the method or operation is not implemented. Beautiful. Here is a failing test. Let's go make that test pass, shall we? So let's go in here, create library card, and we'll do exactly what the test asked us to do, right? We're going to go here and say, okay, well, first of all, here's my library account, added library account equals await this dot service. So that's your library account service that add library account async, and I'm adding the library account to it. So far, so good. And then the second thing I want to do is that I want to go here and say, well, this is my library card, and this added library card async, and this library card async needs to be something that is mapped outside of, so I can go here and say private static. Is it going to let me do static because it has, oh yeah, I guess it would. So this is your library card, like this. And this is create library card. And here's your, you know, I guess you could just pass in the library account ID. And this guy will literally return new library card like this. Yeah, it's multi-liner. Let's not joke around with that. Let's go here and say return new library card. Here you go. And this library card will have an ID. Sure. GUID.NewGUID. We don't care. Here you go. And then the library account ID will be the library account ID. Like this. So we're returning a library account. And in here I can go and say, okay, since we have to do mapping, and these two, you know, listen to this very well, because a lot of people do that. So this is, you know, input library card, create library card here, and you're passing in the library account ID .id like this. A lot of people will go and say, oh, let me just pass this in here and we're done, right? But that's not good. Why is that? Because you have two statements that aim towards the same purpose. So why don't you take both of these statements and just put them in a method and just say add library card or create library card here. Create library card async. So these two statements, see how you're collapsing, because both of these functions, the mapping and the inserting, is targeting one purpose, the exact same purpose for that same model. One of them can't go without the other, right? Like there's no point of mapping to a library card if you don't have, if you're not going to add it, and there's no, you can't add it without having the model. So that's straightforward, right? So this is your clean code here at this point, right? And then the last thing I want to do is just to go here and say return, and then return this added library card. There's a trick that I'm going to do in a second, added library account. This technically should make your test pass. And that's an orchestration service in real time. You're actually building this and you're creating these details and all that. If I go here and say, okay, let's run this test like this. There we go. It's passing, right? So it's doing the right stuff. No harm, no foul, right? Okay. So now that your test has passed, let's go back to this test. So it basically added both a library card, but there's a problem here. I can literally still make that test pass even if I didn't honor the order, and that's very dangerous. I can go back here and I can do this. Check this out. I can go here and say, well, this nice add library card thing you have. Hold on, did I click the wrong thing? Where's my orchestration service? One sec. Control minus will take me back to wherever I started. There's this guy, and if I double click on this guy, it'll take me here. Yeah, check this out. I can go here into my create library account, and I can switch those. I can just go like this and put this guy up and put this guy down, and that will cause a huge problem. Why? Because one of them is dependent on the other. One of them literally says you have to call me first, and that's the point of orchestration. That's what makes an orchestration service, you know, more advanced than an aggregation service. An aggregation service just says call all of them, I don't care, in which order, it doesn't matter. But your orchestration service literally says, no, there is a particular order that I need to call these things in. Sometimes it doesn't, that's fine, but it still unifies the model, and you know, one of its purposes is to do something like that. If I put that order like this and run again, watch this. The test will say absolutely 100% good test. See? And that's back to our discussion about whether your unit tests should really care about how things are implemented within the method or not. That's a huge problem because you're trying to create a library card for a library account that doesn't exist yet. So what are we going to do then? Right? Okay. Let's go back to the mock and let's do something a little more interesting. I'm going to go here and say mock sequence. New mock sequence. And every time I try to set up one of these libraries, I'm going to add the mock sequence to it. So I'm going to go say in sequence, and here's my mock sequence here. So this is number one, mock sequence. And I'm going to have to set up the other one as well, right? Wait a second. Am I in the right place? I'm not in the right place. Hold on. Yikes. One sec. I always click on the wrong test here. That's bad. Okay, let me go to the right test. Where is it? So this is my account orchestration service. Yep, let's go back here. Yeah, let's do that mock sequence stuff. There's mock sequence. Yeah, it's actually mock sequence. Okay. And this mock sequence will allow me to go and say, oh, this has to be called in sequence. And we have to honor that mock sequence like this. And here's this, that library card. It will force you to actually do the little shindig with the services, but you have to. You don't have an option. Add library card, and I don't know, whatever, you can go here and say, it is any library card. Let's go. Here we go. And then this guy returns a set. You don't even have to set up a return anything. It really doesn't matter. You just need to set it up and say I want it in that particular order. Now if I run this happy test that we just had a second ago, this test will be like, nope, survey says no. You can't actually pass this way. You shall not pass because your verification is not correct. See? What? Did it pass? Hold on. Let's see. Operation Cul-De-Sac. Let's see. Mock sequence, in sequence, and then library card service. Do I have to make it strict mode? I think so. Let's go here. Mode behavior strict, I think. Something like that. Let's see. Boom. So what is this guy saying? It's saying add library card. Invocation failed with mock behavior strict. Must have a corresponding setup. This guy must have a corresponding setup. Let me do this. Expected. It is same card as expected input library card. Let's just see if this does the trick for us. Let me break this guy. Because I really don't care about the return, but I really care about the setup. This one is important. Responding setup, and let's see here. Let me run all of this again. Come on, get me there. Something like this. So if I go, let's just start with this. If I go into the implementation and I move that library card down by 1, like this, and take that guy out. If you want to move lines like this, you could just do Alt up and down, and it'll do that trick for you. But let's just see if I run it this way, does it become happy? Invocation needs a return. Ah, that's why. Okay, fine. It really wants a return value, and that's okay too. We can do that. We can go back to the setup here and say returns async expected input library card, like this. Let's run this again. Okay, now if I go and fix the order of my setup, let's go to the implementation, take the library card, put it down here by 1. Let's run this again. Let's see what happens. Boom, it passed. Right? So just adding this mock sequence situation, it's really verifying that these particular, and I think there's even, like, hold on, I think there's even a better way than actually putting it in strict mode. I'll find you a better one. There's even a better way. This works, but I'll find you a better one because it's not really, like, I feel like the message is really poor, and I don't really need to say things in strict mode. That's also dumb. I don't want to do that. I don't want to put things in strict mode. I'm a little stubborn, and I don't want to do that here, right? So let me just find, the latest and greatest in mock. So mock setup in sequence. There's an easier way to do this. I'm just too old. I don't remember. Um, nope, that's not it. Let's see. Mock sequence. This guy here. There you go. Validating call order. Yeah, so you say in sequence and then setup, and then you verify in that particular order. Yeah, that's what I thought. So you're creating a sequence, and you're saying in sequence, you pass in that sequence, and you say, okay, this is supposed to be in that particular order, and in that particular order, things are supposed to work this way. Yeah, that's what I thought. That's what I thought this should work like. So I don't need strict mode. I don't want you to kind of take this from me and be like, oh, Hassan said it's supposed to be in strict mode. No, it doesn't. It does not. It doesn't need to be in strict mode. I don't know, honestly, like, let's see. If I run this now, this guy will pass, I'm assuming. Okay, and if I go and shift the order of my calls, let's go to the implementation and move this library card up above like this, and then run again, this guy should fail. Ah, really? Fine. Man, that guy is stubborn. Okay, fine. Um, hmm. What if I made a return type for it? You're gonna have to come up with a simpler solution for this one. But if I go here and say, okay, fine, here's your return type that you're so happy with, does it care? Huh. And if I go down here, I still have the library card up, and I'm saying this is my mock sequence, library account, library card, add library card, and then library account verify, and then library card verify. Fascinating. Okay, fine. You win. Let's put it in strict order and let's do it this way. Here, let's go here and say strict mode. And let's put this in strict mode, mock behavior. I just want to make sure that you know this part. How it's going to be implemented, there might be an easier and funnier way to do this. I don't know it yet, but we'll see. Okay. All right, that's great. That makes me happy. At least I can give you a failing test that says, yeah, you can actually verify this in that exact order. You might need to fix the variable names and all that, but that's okay. All right. Do we have a properly implemented orchestration service? I say yes, right? But I'm gonna give you, like, for the people watching me here, I'm gonna give you something to think about in terms of validation, right? You may add another additional tiny thing in your test that says make sure that whatever is being passed in terms of expected does not have an empty GUID, because I can very easily go here and say, hey, instead of that GUID like this, I'm gonna make that GUID empty, like GUID.empty like this, right? And if that's the case, you go and run this guy and it just says that's totally okay. So now you have a problem in your test because you're basically saying I found a loophole in my test that tells me, oh yeah, this ID can be, while I don't care about the content of the ID, I really want to make sure that this ID for the library card that I'm passing in is not an empty ID. So what are we going to do about that? I'm going to go down here and write another rule. And the new rule will be that the expected LibraryCard.id, right, should, let's see, do I have should here? Come on, come on. Wait a second. ID does not equal GUID.empty. So this way I added one tiny rule that says, hey, you can't really fool me. I don't care about the ID that you're generating internally. But if I'm running my orchestration service and you're putting an empty GUID in there, I'm going to have this test fail. Watch this. Actually, it shouldn't be on the expected. It should be on the actual. I'm sorry. And now this guy will fail. Come on, fail like a good person. Look at this. So now you can't fool me. You can't fool my orchestration service tests. Right? Because you can't actually go and say, oh, let me just slip in a bad ID. And this orchestration service won't know better. Now you can capture that. All right. So as we're working towards an advanced concept in Cul-De-Sac, I'm teaching you a whole bunch of things in the middle. This is the real deal, right? This is not some side tutorial where I'm just showing you one tiny piece and telling you go and figure it out on your own. No, this is the real deal. So now that my test is actually failing, let me go back to my test here and let me go and say, now it's actually considering this not to be an empty GUID, and therefore I'm going to have to generate a new GUID because you don't have any other option. Like, the beautiful thing about this is that GUID either going to be empty or it's going to be a value, and I don't care about the value, but I really care that it's not empty. And now if I run this guy, it's going to be happy because I captured that guy in real time, right? I busted it, right? There you go. Now you have a clean orchestration service. In my book, if you write your orchestration service like this, you're writing really advanced enterprise level concepts. You're testing for order. You're testing for, input parameters. You're making sure that your data is in the right format. Normally, when the data is generated, you care more about, there are things that you care that needs to be there in the exact value, and you care about things that just needs to have some value in there, and that's it. So where are we on the map, my friends? We are now have arrived here in this stage. Now, here comes the fancy part. This is advanced software engineering for you. At this level here, we want to fix this guy to allow its listening function to have a capability that takes in an input parameter as a func. And this func that's coming in as an input parameter, we want to make sure that it gets executed after the orchestration service have executed the capabilities that it cares about. What does that mean? It means that when the event comes in, I don't know what happened to this arrow in here. It means that when this event comes in here, we don't care about this client. When a student event comes in here and we pick up that student event and we go and create a student, this part needs to really happen first before whatever input parameter that is being passed in here from this coordination service gets executed and implemented. How the heck are we going to do that? How are we going to do that? How are you going to execute two capabilities within the same function? And then you actually go and verify that actually this happened, right? Let's just look at the code so you understand the depth of this problem, right? What I'm basically saying here, first of all, change of signature. That means you're going to break a lot of things, right? Let me just, okay, that's great. Let's go into our orchestration service in here. So this is your student event orchestration service. And we want to be able to pass a parameter to this guy and make sure that this parameter got executed. So I need to go here and say pass in a func, right? And this func will take in a, its result is just a value task. And its input parameter is the student itself, the student entity itself. So this is your student entity, and it spits out a value task, right? And then we're gonna go here and say student event handler. And we want to be able to go and say execute that event handler, ensure that this student event handler actually got executed, after we have added the student. So there's two challenges here, right? The first challenge is passing that parameter in and making your test understand that this is how things are going to work now. Let's go fix our test because your test won't even build at this point, right? Let's go here and make this test driven because you changed the signature. It also means that you need to change the signature in your interface before you do anything and everything. So let's do that. Oops, we don't need the void. Here you go. This guy, and then let's pull in some parameters. So now you're turning into the exact same model of your student event service when you're taking in a parameter as an executable function. Remember, you guys, like if you go into the student events in here, you can see that we were passing a student of a function a value task, and we executed that internally, except that this is a little bit different, a tiny bit different, because the listening here is different. You're basically not listening anymore. You're going and saying, what did we call the event student? Listen to student event? I guess it's listen to student event then. It should be just one event, not events, right? So let's fix our test, right? So I'm gonna go into the orchestration service, student event. Let's go down here, and instead, look at this. Now I can go here and create a mock of some function, whatever that function is, and then verify that this function has actually been called. So here, this is student event handler mock equal new mock, right? And this guy takes in a func of a student and a value task, and that's it. That's my mocked up function that I'm gonna pass in. The object of this function will be whatever I pass in. So that means I can go here and say, here is your student event handler, and that is your student event handler mock dot object. Will this guy be happy? I think so. It should be. Now, if you run this test right now, it'll just pass because there's nothing else you're doing. If I go and run this guy like this, it'll just be like, oh, okay, you're not doing anything with it. Oops, hold on. I forgot something, I think. Oh yeah, that listen function. Let's disable that function for now because we're not going to need that. It's going to be somewhere else where we're listening to events and coordinating this entire structure. This is really fun. You guys are going to love that stuff. So yeah, so it's listening it, it's running, and it passed the test, right? All good and dandy, no problem there. But that's not enough. I want to make sure that this function actually got executed and got called within that realm of things that are happening. So how am I going to do that? I want to go here and say, well, you know, this guy here is going to be a student event handler mock.verify, right? And whatever this handler is, you know, let's say handler, you know, with incoming student. So I'm verifying that exact input parameter, right? So this is my handler. And that guy has to be called at least times once, just like that. Okay? So now let's go and run this guy. This guy should fail. Aha. And why is this guy failing? Because he said, hey, you said that this handler is going to be called with that student, but you didn't. It didn't really get called. So now I have a new failing test. So now the test again is driving the implementation after I've made sure that the test is in good state. Right? So that means I can go back into my implementation here. And I can go and say, well, in here I'm going to say await and then student event handler. And I'm going to pass that student as a parameter. So I'm passing a function to a function, and this function is executing. I don't know. I think that's what they call monad. I think so. I don't know. It's above my pay grade. I don't know. So let's go back into the test here and run that. Does this one pass now? Pass. See how simple that is? You just changed the function, you wrote a failing test, and you're passing in an event, and you're making sure that event actually gets executed properly, right? Now, I want to test something else. I want to make sure that these things have happened in sequence because that's also important. I want to make sure that my orchestration service is actually calling these guys in order. Like right now, if I go in here and say, oops, hold on. If I go into the implementation and switch those like this, there is absolutely no problem there. Nothing is going to happen. Nothing is going to happen. Right? And you can rely on um, a operational dependency that your event handler actually needs to wait for whatever the add student async is returning before you actually execute that function. So it needs something from that student, and you can play the game of, oh, the expected has to match exactly whatever comes back. You can play that game. I respect you for that. That's actually would be one right way you could do that, right? Or you could basically go and say, well, let's do the sequence again. Let's be more explicit. And to be honest with you, like either way you're gonna take in here, that's okay with me. As long as you're hitting that target and your excuse me, and your code is still readable and understandable. If you do that, you're in my good book, right? So what does that mean? I need to go here and say var mock sequence equal new mock sequence like this. And then I want to go and say in sequence, and this is your mock sequence. Oops, mock sequence like this. And maybe I want to go here and say student event handler, oops, student event handler mock dot in sequence. And here's your mock sequence. Come on, man. Sequence dot setup, and then I don't know, handler with the input incoming student, like this, something like that. I don't know. Would that work? I don't know. Let's make the test fail first. Let's keep things as is. Oh yeah, this is the bad state that the test is in. Let's go and run that and see what happens. Here we go. It's passing. Why is it passing? Because it needs to be in strict mode. This guy as well. Okay, fine. Let's do that. Sounds good. So this is behavior. Come on. Mock behavior dot strict. And that means my other dependency, which is this guy here, needs also to be in strict mode. Mock behavior strict. Or is it the other one? Hold on. This one. Like that. Would that work? I don't know. Let's find out. Boom. Failing. Expected this mock to happen, but it never did. You know, something occurred in there. What if I go and fix this guy and put it upside down like this? Let's go back here. Let's run this. I also think it was probably complaining about something else. It's saying add student, incoming student. Is it complaining about, let's see, does any sequence verify, and then this guy got called. Oh, I think I need to also set up the, yeah, so this dot student service dot in sequence, mock sequence, and then set up service, and then service dot add student. It is any student. Is you can just call it incoming student really, like that, and I can go and say returns async. Again, the incoming student. Right, let's see what kind of error we get now. We gotta make this work. Don't worry, I got you. Not going anywhere. There you go. This guy's passing, right? So that means if I go and switch that order again like this, I should fail. I should fail. Let's see if I switch that order like this. Come on, fail, 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 fail. Fail, fail, fail. There you go. saying this invocation didn't happen exactly the way I expected you to. So that's super important because we verified everything here. This is what I really want, right? I want to go and say, no, you have to actually match the order of which I want these things to be called. This is what I love about this. This is very advanced topics. You know, it's going to get you thinking about how your software is implemented and how it's working and all that. Okay, so let's go here. Let's run this guy. I wish the mock message was a little bit clearer. I'm pretty sure, swear to God, there was a better way to do this, but here we are. It's okay. So this guy's done. Yay! So we're getting almost to the end of this. You know, just about 2 hours later. So let's go back here. So this guy is done. This guy can take a function from here, and it can pass this function. So it can correspond to an event, subscribe to an event, and then based on that event, it will pass its own handler to get executed. But that handler in and of itself is actually something that can process students, work with students and stuff like that. Right? All right, let's do this. So let's go to the coordination service. So now let's set that guy in orange. Let's go down here, and now we want to create coordination services. So here's a new, this is the very, very first time I create actually a coordination service on my channel. So this is your time to ask me questions. Here's coordinations. And we're gonna call this, what did we decide to call this? We called it Student Event Coordination Service. Sounds good. Because the main entity here is the student event. So okay, student events. And then here is your coordination service. Let's start with an interface. Student event coordination service. And this guy is just gonna have a listen. So about void listen to student events. There's no magic there. Just a very simple guy, and that's the guy that's going to be exposed. And we're going to run this end to end. We're going to do it together. We're going to have a lot of fun. Okay, so this is a coordination service. That means it works with two orchestration services, and it's doing a lot of magic in and of itself. It's doing a lot of magic. So this is going to be student event coordination service, like this. And this guy is going to need some dependencies. So student event orchestration service, that's the first one, because that's where it all starts. So this is student event orchestration service. And you also have private read-only what is it? The library account orchestration service. Remember that guy? The guy that we just built earlier, like an hour ago? So this LibraryCard orchestration service. What else do I want? I want student event coordination service. It's really creepy that I kind of figured that out on its own. That's really weird what this guy is doing. So it's not just read-only. We need the mock version of these, right? Let me show you another trick. If you do Alt and just drag down like this, you can type in 2 lines at the same time, like just like I'm doing right now. How crazy is that? That's pretty cool, huh? But then if they're not the same length, now you have trouble. Oops, what did it do? It generated, come on. Mock. Why it doesn't know what a mock is? Mock student. Oh, because I'm not in the shoot, I'm sorry. Because I'm not in the test yet. I'm not testing anything yet. Sorry. Okay. And I don't need this guy anymore. That's why it knew what the service is. Okay. Now let's go here and I do student coordination service. And I don't need this CTOR. And I just need to create my own with parameters. It'll be like 3 miles long. Yeah, don't do that. You'll see people writing code like this. Yeah, don't do that. That's not, there's no readability there. That's not professional work. You're a software craftsman, you know, own it. Own it. If you're building enterprise systems, people trust you to build these systems, own it. Seriously. Okay. So we have this service, and now we need to write a test that says, oh, you know, we're gonna call that event, and that event is gonna do some stuff, and we're gonna be calling the account service. The idea here is that you're getting that orchestration service call in, and that orchestration service call, you're already registering that. We're going to be registering through that listen to student events function, which will be listening. But as soon as the event happens and the message comes from the queue through, what's going to happen is that it's going to actually execute some functions and then execute the additional orchestration work that you want. So it will go and create. The message will come and go all the way up here. I'll say, oh, okay, then execute your stuff, and then go ahead and go and create a library account and a library card and all that good stuff that we were talking about. All right, so let's do that. Let's go write a test. So under services, I'm gonna create coordination. Let me take my face away. Didn't need the face here. And then here's the coordinations. And then I'm gonna create another folder here that's called student events. That's your student events coordination service. And then we're gonna create a class here, and this class is gonna be called student event coordination service tests, like this. And then we're gonna go and say here's a public partial class, and now we do the mocking stuff. So this is mock student event orchestration service. This is a student event orchestration service mock. It gets the word's getting bigger and bigger, you know, because of the complexity of the work that we're doing. And then library account orchestration service. So these are my dependencies. Is your library account orchestration service mock. All right, and then I want my service. So this is student event coordination service. And then let's go and just do the instantiations. Student library account. So all of this is fun and games until we try to make this actually work. Let's see, student event orchestration service mock. That's right. Service. That's right. And then this guy is mock as well. Come on, give me something. There you go. New mock library account orchestration service mock, just like that. Okay, my friends, we're almost there. All right, let's go here. So it's okay, and then I'm gonna go here and say this dot student event or coordination service, and this guy will equal student event coordination service. And now I have student event orchestration service, which will equal student event orchestration service mock dot object. And then you have library account orchestration service, which will take this dot library account orchestration service mock dot object. We're still within 120 characters, so we'll be just fine. We will be just fine. Okay, perfect. What's the next thing we need to do? We need to run some stuff. We need to make sure that, you know, we are listening to the event, and then the event happens. The exact same fun stuff that we did over here when we went and said, hey man, you know, when an orchestration service event for a student event happens, we need to create some random student. We're still going to be creating random student, and then we're going to be setting up that event service that it does stuff, and then we're going to take that event and invoke it with, like, we're going to actually pretend that the message actually came through, and then see what happens. Like, we see what actually executed. So all we have to do is to verify that we actually called the library account with the right stuff. That's it. So we're kind of compiling all of these amazing advanced engineering concepts together, right? So let's do that. Let's start from the top here. I'm going to go here and say, okay, so we need a student, right? So private static filler. Zoom in a little bit so you can see student. Here we go, here we go. create student filler, new filler student, and then private static student create random, come on, student, create student filler dot create. Right? Here we go. Says so far so good. Now let's partialize. This guy's already partialized. Let's copy this guy and let's throw it in here. And let's go and say dot logic dot listen. Right? And this listening piece is the good piece. So I'm gonna take all of that junk away. All of that. Still need to close the class though. Here we go. Here's fact. Oops, fact. And then let's do this. So we're going to go here and say public void should listen to student events or event given when then. There we go. And then here's your student random student, so just student coming from the outside world from a queue, trickling all the way through your architecture and then coming all the way back. It's beautiful. It's cul-de-sac, right? There's no controllers. There's no access from anywhere else. You're just building a listener, right? And then here's my student, incoming student, incoming student, right? So here's that, your random student in here, right? And then I want to go and set up this event, right? So this is my mock here. This is your student event mock.setup, and there's your service like this, and then listen to student events, and this guy will take it is any, right? Func, come on, func that takes in a student as input parameter and returns a value task. That's what this guy cares about, right? As input parameters. So we gave it what it cares about. Now what are we going to do then? We're going to go and say the callback piece, right? And this is the fun stuff. So this is the event handler, and then we're just going to invoke it. So this event handler is this very func. I'm just going to invoke it. Invoke. Oh, do we need to map it? Fine. Func of a student and a value task. Sure. And then we're going to take that guy down by 1. This is called beautification, uglification. Like if you're really cringing because I break my order with tabs like this, we can make a special video just about that part. This is your incoming students. This way the people who didn't watch the first video, I literally invoked, I pretended that a student actually came through the queue. And that took me a long time to just figure out. But we figured it out. It's here. Right? Now, what do we need to do? We need to verify that we are calling this add function properly. And then we're going to complicate our test a little bit. So I'm just going to go here and say this.service. Come on. Service. Student event coordination service that listen to student events. And then I want to go here and I want to verify. Here you go, student mock, that student event orchestration service mock. Verify that this service has been called. Look, listen to student events with whatever is in here. Verify that this guy has actually been called. So this is the first piece. This is like basic cable. You're basically saying, yeah, I have been called once. That's all. But what else do I want to verify? Here comes the fun stuff, right? I want to go here and say this other mock, the library account. Here's my service. I want to know that my library account has been called with the right student ID. Just like how we did with the library account and the library card, I want to do exactly the same thing in here. Don't care about the library account ID as long as it's not an empty GUID, but I really care about the student ID that is being passed in there. So how are we going to do that? Let's go here and say it is same same library account as, and then I want to create an expected input library account. So this is library account, expected input library account. And here's your library account. And this library account will have an ID. Don't care. Right? And I want a student ID, which will be the incoming student.id. That's the one I really, really, really care about. Var, there you go. That's your guy. So this will be, it is same library account as expected input student account, and this guy needs to be called at least once. So that means we need a function in here. We need this expression func thing. So private, static, expression, here, func, come on, func, and then takes in a student and returns a boolean, right? And then same library account. Why did I say student? It's library account, right? Library account. Come on. Visual Studio is done with me today. It's been like, come on, man, 2 hours. Seriously. Library account, expected library account. Let's break that guy into the next line real quick. And then here's what we, oops, turned into F sharp there for a second. Let's go here and say return actual library account. And what I really care about, like I said, that the actual library account dot student ID equal expected library account dot student ID. So that's number one. How tall is this guy? That's 110. That's fine. And then let's give it the other one now, which is and actual library account dot ID is not GUID dot empty. We already talked about this. Slowly but surely you're catching these little concepts, and hopefully it's enriching your experience as we go. Visual Studio here is telling me, oh, simplify this and make it like this. No, thank you. Like Visual Studio is saying, oh, since the left side is clear, why don't you just simplify your function like this? Actually, in the real world, you'll never end up doing that because there are some different properties and types that you don't get to actually build like that. So you're really going to need a scoped thing, but I don't subscribe to the whole left side is clear, so the right side is just new. I like the right side is clear, then the left side will be var. It's just my preference. So now I can do the same library card account. I think we just don't have enough closing parentheses. That's really what it is. Yikes, look at all these. One, oh, so this is 1, 2, 3, 4. 1, 2, 3, 4. Same library account as. Did I call it same student as or something? Here, same library account as. It's just the naming convention. Okay. What do I need here? All done. Now I just need to verify that my mocks has been called in the proper, has not been called outside of this realm, which is really, really important. So verify no other calls. And here's a verify no other calls on the the library account orchestration. Do I need the order here? Do I really care about the order here? No, I don't. I don't care about the order here. Why? Why is that, Hassan? Because you can't actually execute one without the other. It's relying on the event that has been executed, right? So let's run this test. Let's go here and run this test. Come on, come on. Fail, fail, fail. And fail for the right reasons. This guy should say not implemented or something. Okay, perfect. That's a good start. But is it actually looking for the right stuff? We don't know yet. We'll see. So this is a fail. Now let's go ahead and implement that good stuff. So let's go to listen to student event. And let's do this, you guys. We're going to go here and say, okay, so what you want me to do here is to call the student orchestration, event orchestration, and then listen to event. And then you have this student guy in here, like this. And I'm going to await that guy. Sorry, async. And inside that guy, you want me to do the magic, the little stuff, right? So in here, it basically wants me to go and say something to the effect of, I want to be able to call this function. So this is var library account equal new library account. And this library account will have, I'm going to make it really pretty in a second. This guy is going to have its own GUID ID. As long as that ID is not empty, I should be fine. There is this GUID. There's that guy, and then you have the student ID. And the student ID is this incoming student that you have, .id. And once that's done, I can now go and say await this dot, the library account, and then go and say create library account, and here's your library account done. This should make our test pass. And that would be the last thing. Well, we're gonna need to register all these services that we created, but that's the last thing in terms of implementation. Let's go down here to the test method. Let's run this guy. Pass. Yay! See, it's great. It's simple. We basically trickled bunch of events, but this is all great. Like Mike Tyson will tell you, every man has a plan until they get knocked in the face. So is this really what's gonna happen to us right now? I don't know. We'll see. Let's combine both of these together and put it in a method, and just say add library account, add student library account. And this guy is private, so we should be just fine. And since this guy is a one-liner, let's even simplify the world. Just a tiny, tiny function that just does something that's really amazing. Okay? All right, so this is all great. Code rub, cleanup, coordination code. And now we get to go back into, my dear friends, we get to go back into startup.cs. This line that I kept kind of commented in here, instead of this iStudent orchestration service, it's going to be iStudent event coordination service. This guy here. And now everything is as is. We're not touching anything. Everybody's just fine. But we still need to register all of these foundation services that we created, right? So these guys are still important. So I'm going to go here and say, here's your foundation services. So this is what LibraryCard service. I should have registered those as soon as I created the foundation service, because you will forget that stuff. I am sorry. I'm just trying to kind of get you as much information as possible in a very short time. So this is LibraryCard, and also I want library account. So this is library account service, and this is library account service right here. Okay. Now let's be nice and let's keep things in the right order. So this guy is a student service. This is student event service, and then library account first, and then library card second, and then we need an orchestration service, right? So let's copy this guy. This will be library account orchestration service. So that's this guy. And then the last one is the big guy, the last guy, right? We need to register Mr. I student event coordination service. Student coordination service, this guy here. Done. So we registered all of these guys. Now the moment of truth. Now we're gonna need to run this system and see if all that stuff, like I could very possibly build all of that stuff, and then at the very end it just says nope, it's not gonna work, and the whole thing is broken, and just go home, Hassan, and find a better thing to do with your life, right? Let's see, let's find out, right? It's fun, right? It's all fun stuff. How do we know we're doing the right stuff? I'm just gonna put breakpoints. And these breakpoints will tell me that actually the things that I'm expecting to be executed are actually executing. This is all I care about. We're going to go to Azure. We're going to put a message on the queue and see that message trickle through and create, all kinds of great things. It'll create a student, and it'll create all the good stuff. Let's run this. So it should spin up a little. Yeah, there you go. Just it starting without blowing up, that's a great start, right? Because that basically means it's registering. Like as the service is starting, it's actually registering to this particular queue. Now let's go to Azure. Let's go to Azure. Azure wants an ID and a name. We just put that message on the queue and that's it, and call it a day. So let's see if that's the case. So Cul-De-Sac bus, and then if you go to the queues, student queue, let's go to Service Bus Explorer. Let's zoom out a little bit for people just so they can see the stuff. Let me minimize this. Azure UI literally changes every day. It's like the weather in Iowa. You know, if you don't like it, just wait. If you don't like the UI, just wait. You know, just wait a little bit, and then the weather will change again. So here's an ID. We need a GUID. Let's find a GUID. GUID generator. Give me a GUID. Here's a GUID, and we need a name. So let's put Elbic in here. Okay. Moment of truth. Let's put a breakpoint at this coordination service layer, which is the highest layer in our architecture here. I'm going to put a breakpoint right here, right, and see what happens to us. We don't know. We'll see. It might work. It might not work. We'll see. So here's the send request. Visual Studio. Is it listening? Nothing. Let's see. See? Something happened, right? Let's see. Receive, refresh. What? It said it processed it. What? Did that really happen? Let's go pick up our database and see what happened. Did I not capture the event? Let's see. Tables. Students. Select top 1000. Oh, it added Elbic right here. I don't know why it didn't catch the breakpoint. I hope I didn't put it in release mode. But if it did add Elbic, that means it also did create a library card and a library account for Elbic. And that's the moment of truth, my friends. Let's start with the accounts. Let's see. It did create an account. Does this account match the student ID account? Yes, it did. 9A. 9A. Oh my God, this is actually working. And then if I go into the library cards, it's having, it should match the library card ID. So this is the student. This guy should be FF. Then this guy should be FF. We made it, you guys. So that's one little message going through this entire queue all the way from here to there. And then it actually created a student. It created a library account, and then it created a library card for that student. Right? Of course, when you add the validations and all that kind of stuff, if the library already exists, it will go and say, but you can see now you can append more and more flows into this, and then you can go and build management service on top of your coordination. So like if your coordination service is living here and you're working like this and you're saying, no, I have more scenarios, absolutely, let's go and create 2 coordination services at this same layer like this, and go ahead and slap in there a management service. You say, well, I need more management service. I'd start questioning your business logic at this point, right? I would start seriously questioning what you're doing, but the architecture will support you. It will say, okay, go build an Uber management service. And then if you say, no, I want multiple Uber management services, I'll be like, okay, let's come up with something that, you know, a new name for it. But at this point in time, I would really be concerned about what you're doing. If you want to see, so this is really important. This is very advanced stuff, you guys. This is not stuff that you know, it's very helpful when you're building, you know, services in a way that, you know, support enterprise, message-based and all that, but this is an actual working solution for you. I built it with you end to end. It doesn't have all the other stuff like rollback and validations and exception handling and all that, but there you go. So I'm going to go here, gladly, I can go here and say coordination and say listen to student event. And that's done. So you'll find all that stuff. Where do you find all this awesome code? You'll find it in a branch. I'll even create a pull request for you. Let's go here, go to GitHub. like this. Let's go to what's this project called? Cul-De-Sac. There you go. Here's this guy, and this here I'm going to say coordination. Listen to student and create library details, right? And I'm going to create that in draft mode. So you'll find that in the cul-de-sac. I'll even put the link there for you to kind of, be able to see, what to do there and all that kind of stuff. All right, that's our journey there. Fail, pass, fail, pass, fail, pass, test driven, all the little details that you could possibly need to basically build an enterprise level system. We made it. Okay, I hope you find this useful. Don't let that knowledge just stop there with you, right? There are three kinds of people that watch my YouTube videos, right? Some people just watch it and walk away. They don't do anything with it, right? And some people will watch it and go tell other people. They go say, hey, check out this video. This is really important. We can use this in our work, in our enterprise system, in our daily job, or this project that we're building, and they go and learn from it and teach others. And there's the third type, which will learn it, teach others, and actually do it, start implementing it and working with it, and ask me questions and debate with me over it and tell me, hey, Hassan, I don't like this approach and all that. Don't be like the first kind. Don't let that video just pass by you. This knowledge that I'm giving to you right now is very, very precious. 21 years in the software industry tells me that this knowledge is really a lost art. So make sure you learn that. Make sure you know how to architect your system and make sure how to build things that are useful for you, and hopefully it will fill your life with prosperity and happiness and be able to kind of even build even better patterns and better systems other than this. I hope you find this useful for you. As usual, if you have any questions or comments or concerns, please feel free to drop a comment in the comment section, and don't forget to like and subscribe, and I'll see you in another video. Take care, have a good day.